Hello, my name is Robert Fromont. I'm from the New Zealand Institute of Language, Brain and Behaviour at the University of Canterbury. I'm just going to very briefly describe the corpus annotation system that we have developed called LabCat. LabCat is essentially a system that stores recordings of speech and their transcripts and allows you to add layers of annotation on top of those transcripts. Once you've got the layers of annotation there, you can search for patterns in the annotations across different layers. With the results of those searches, you can either explore the data directly within LabCat, or you can export the results to CSV files for further analysis and other tools. You can also do batch acoustic measurement using integration with Pratt, and you can export the transcripts out in a variety of other formats. Now I'm going to talk about each of these things in a bit more detail. First, I'd just like to give a little bit of context. We started developing the tool in 2003 as part of the Origins of New Zealand English, or ONZI project. But since then, it has been used for a number of different corpora. Corpora including not only New Zealand English, but other varieties of English. For example, American English, Liverpool English, Glaswegian English, and also other languages as well, including Māori and German. Now, because it has been used with a number of different corpora, and those corpora were transcribed using different tools, LabCat can accept a number of different transcription formats. The original ONZI data was transcribed using a tool called Transcriber, so you can upload transcriber transcripts, but you can also upload Pratt text grids as transcripts, ELAN files, chat transcripts, and it's also been designed to support uploading the Buckeye corpus, which uses X-Waves files. Here is a picture of the batch transcript uploader tool, which is a program that basically lets you drag and drop the Buckeye files, or indeed any other corpus files, on top of the tool, and it will upload them for you, saving a fair amount of manual work. You can also use plain text files as transcripts as well. And there's one further way to get data into LabCat that we've added recently. You can specify speech elicitation tasks that include a number of different steps where prompts and texts are presented to participants in order to get them to speak. Their speech is recorded and then uploaded directly into LabCat. This is done via a web browser, and there's also a mobile app that lets you run these elicitation tasks. Now, how's the data organized? Well, at the top level, you can divide your database into different broad collections. For example, in the ONZI project, we have 3 collections of recordings: the mobile unit, the intermediate archive, and the Canterbury corpus. And each of these is set up as a separate corpus within our LabCat database. Again, in the case of the ONZI recordings, many of them are long interviews that have been broken down into chunks, and each of the chunks has been transcribed separately. And LabCat draws those chunks together into what is called a series. A series is basically all of the recordings that appear together in the same recording episode. Now, the transcripts can have different metadata applied to them. They can be categorized. For example, you can specify that a transcript is an interview or a word list or a reading. You can also specify the language that the recording was in, and in fact you can define whatever metadata you like to attach to transcripts. There are also participant records for recording information about speakers that appear in the recordings, and they also can have metadata attached to them: gender, date of birth, and whatever else you like. Now, once the transcripts are in there, you can add layers of annotation. Here are some examples of manual annotation layers that you might apply. For example, you can add topic tags, which mark out long sections of a transcript as being about a particular thing. You can tag a number of words or a phrase as being in a different language. You can add annotations for noises. You can add commentary. You can mark named entities, and you can generally tag words with whatever you might want. Now, these are examples of manual annotations. There are also a number of modules that perform various automatic tasks for annotation. For example, you can tag words with their values from particular lexicons. For example, the Celix lexicon includes phonemic transcriptions, morphological pauses, part of speech information, frequency information, and each of these things can be a layer of annotation that you add to your transcripts. LabCat supports a number of different lexicons. You can also compute frequency information from your own data and have words tagged with their frequencies directly in your own corpus. If you have syllable count information, for example from Celix, you can calculate speech rate. You can detect and measure pauses. You can tag words with the amount of time that's passed since the last time that word was mentioned. You can do various types of pattern matching, syntactic pauses, and there are a number of scripting languages that are supported for doing arbitrary automatic annotation. Now here's a picture of a part of a transcript with different layers of annotation added. You can see at the bottom there are some words which make up the original transcript as it was typed into transcriber in this case. Above each word you can see that there's a number, and that is the frequency layer. That's the number of times that that word appears in this particular corpus. Above those numbers you can see that each word has a phonemic transcription. This was arrived at by looking up the Celix database. And above that you can see another layer marked morphology, which are morphological pauses that again came from Celix. Now each of these layers are word tag layers, so each token can be tagged with annotations, but you can also have a broader granularity than that. You can see above the morphology layer there's a syllables per minute layer, and that marks out the speech rate of this particular utterance, so all of the words collected together can have an annotation as well. And above that you can see a topic tag which starts at the beginning of this utterance but also goes on further through the transcript and marks out a larger section. So you can have annotations of various different granularities. Now another type of automatic processing you can do with LabCat is forced alignment. This is a process that takes the audio from the recording and lines up the word tokens with the audio, so you get start and end times of each of the words. In fact, it gives you phone alignments, so phones within the words, their start and end times as well. Now after doing forced alignment, you will probably want to check how good a job that the alignment has done and perhaps correct some of the alignments. LabCat makes this easy by having integration with Pratt built directly into the transcript page. You can open a particular utterance in Pratt and it will give you the audio of that utterance and also a text grid that gives you the word and phone alignments. You can then make corrections to the alignments within Pratt and click a button in LabCat to suck those corrections directly back into the LabCat database. Now once you've got all of this data and annotations into your LabCat database, what can you do? Well, you can search for patterns. Here is a picture of a LabCat search matrix. This particular one involves 3 different layers and goes across 2 words. So here we are looking for words that have the on the orthography layer, followed immediately by a word that includes on the segments layer a fleece or a goose vowel, and also on the frequency layer has a value of 1. Now if you run a search like this, you'll get a list of hits. You can click on a hit and it will open up the transcript at that particular point and highlight the matched words. You can do various things inside the transcript page, but also you can export the list of hits out to CSV files, and you can tick various different annotation layers to include, and then you can use the CSV file for further analysis in Excel or in R or any other tool that can read a CSV file. In fact, if that CSV file includes phone alignment information, you can also feed it back into LabCat so that you can get acoustic measurements of all of the tokens in the CSV file, for example, formant measurements, pitch, intensity, and so forth. You can also export the transcripts or even parts of them out in different formats. For example, you might have uploaded transcriber transcripts, but you can export them out as Pratt text grids or as ELAN files, plain text files, and also PDF and LaTeX formats are supported. LabCat is a browser-based tool, which means that everything you do, you use your web browser. It's designed to run on a central server so that multiple researchers can access the same data at once, although you can actually also set it up on your own personal computer. You can set up password protection and different levels of access for different users if that's required. It's a cross-platform tool, so it will work on Windows, Macintosh or Linux systems, and it's open source. If you want more information about LabCat or you want to download it to try it out, then go to labcat.canterbury.ac.nz. Thank you very much.